Hello, can you hear me? Hello. Yes, can you hear me? Yes. Okay. If you can hear me, so we'll start now. If you can hear me now, we'll start our class now. Uh, so I share the file first. Share the screen. Then now, can you see the screen? Can you see the screen? Tell me. No. You said no. Why the quiz? Why the yes? Abdul Malik Khaled quiz will start at 10. Quiz will start at 10 a.m. Right? 10 a.m. So I think it will start automatically. It will be available in Blackboard. So before 10, we have the class now. We have finished. We need to finish the chapter. This example now. This is the most inshallah. Yes, inshallah. Uh, more complicated or more practical example now. We'll do. Question is same here. Find the shear force and bending moment diagram of the overhanging beam. It's loaded there, right? So here, fine. So the question is, the problem is draw again, draw the shear force, draw shear force and shear force diagram and BMP, right? This is the question. This is the simple question. Now, first we have to First we have to find the reaction forces. We have to find it. Now, how many reaction could be there? This is the roller. And we will have only one vertical reaction, RDV, and here will be the one vertical RAV and RAH will be vertical force. Now, if we take the summation of horizontal force equal to 0, RAH, we have only one horizontal force and there is no other horizontal force. That means RAH equal to 0. Very easy. Now, in order to find, we have to find RAV is equal to how much or RD equal to how much, right? So, for how much? We have to find the reaction force. For finding reaction force, we take moment at A. Summation of moment is 0 and anti-clockwise is positive. So if we take the moment at A, so RAH 0 into 0, AH already 0, plus or minus whatever, RAV into 0 because it is passing through the distance, so the distance is 0. Then we have the force 8 kilonewton, and with respect to A, it is rotating which direction, clockwise or anti-clockwise? Tell me please. It's rotating clockwise direction, so 8 into distance is 1. Then we have the external moment. That is the purpose of selecting this example for you is to this selecting moment. So when you take the moment, then the external moment we calculate, we include the external moment, and this external moment is rotating clockwise or anti-clockwise. I see it is clockwise, so minus 20, because it is already moment, so we don't need the multiply the distance because distance is already multiplied there. And 8, we have the 8 also rotating anti-clockwise, so minus 8 into distance is now 1. Distance is 8 up to here to here, so 1, I think distance is 2 meter. Why 2 meter? 1 plus 0.25, 1 plus 0.25 plus 0.75 distance, right? Then what we have? Then we have RD force, and RD force will be working is anti-clockwise distance. So we write down RDV into distance is 2 and another one 3. So distance is 3. Then we have the distributed force. We have distributed force how much? But distribution force we have 15 into 1 meter distance, and this is actually when this is 15 into 1. So this force will work as a one point, as a middle point, and this middle point is distance is 3 plus here is 1 by 2, that's half, right? and the force is working is actually is clockwise or anti-clockwise. I see it is that it is working the clockwise, so minus here. There is no other force equal to, so equal to, can write down 0. Now you please calculate and tell me, we have now only one unknown here, RdV. Now tell me, calculate please, and tell me what is the result for RdV. Please do the calculation and tell me the result quick. (32). Let me check whether someone else tell me that result. What is the result? 32. What is the correct result? Tell me please. Correct means double check please. (32.167). Another student said 32.167. Right? So 32.167. So 30, come here. 32.17. So 2.17. Just wait, please. Wait. Assalamu alaikum. I'm into classes for. Wait, please wait, please. There kind of the mail function is the, okay, covering, and where is chapter 7? Where is 7? Seems we lost it. Chapter 7, we lost it anyway. We lost it down, and we have to. I have to find it. Sorry. Where it is here? Download here again. Is it? And where here, right? So R A we calculate is already deleted. So we write down R. So what we got? R D equal to 30. This is V actually. dV 32.167 kilonewton. We got the result here, right? We 36 RdV equal to 32.167. Now, if we take the summation of vertical force equal to 0 and upward forces are positive, then what we have? We have RAV. We have RAV. Then minus, we have 8. This is minus because downward. Now, this is moment. So moment will not come in calculation because we are working now with force, not moment, right? So will not come. So another 8 we have, minus 8. Then we have this force is plus RdV because it's upward, so 32.167. Then minus this is the vertical force. This is how much force is there? 15 into 1, right, on distance. So there is no other force equal to 0. So what is the RV? Please tell me the result, please. Please tell me the result. What is the RAV? Shouldn't take very long time because it is very simple calculation, and I expect that you do it very quickly. Tell me what is the result for RAV. Tell me please. 1.167. Yes, correct. Very simple, right? The calculation is very simple. 1.167. 1.167 7 kilonewton. Kilonewton here is 1.167. Now we will draw. We need to draw actually. Now we will draw. What we will draw? We will draw the shear force diagram first. Shear force diagram. We'll draw. So first you draw the reference line is there. Reference line in your reference line. Okay, reference line. Then you draw a reference line, right? Okay. So this time now you see now one question we have this 1.6 is plus or minus. Tell me, is plus or minus? There is another question I think I need to revise. It is plus or minus? Tell me please. It is plus or minus? Tell me. Tell me please. Sanjawad, Tolal Jamal. Tell me plus. How come it's plus? Tell me how come it's plus? Plus or minus? Do the calculation correctly. Do it quickly, please. Tell me. 1.167 is correct, but is plus or minus? It is minus. Okay, now everyone telling it is minus. If it is minus, that means that is downward. We assume we assumed at the beginning it was upward, but after the calculation we got it is minus. That means it is downward force. Actually, it is a 1.167 downward force. In that case, you have to write down like this: 1.167 kilonewton, and show like this. Okay. All right. Now the force is minus, right? So from the, as we learned before, now as we learned before, now we will draw now shear force diagram. So it starts with 0. So first at A, just left side, before the left side it was A was 0. A is just here. Suppose here we just starting calculation, we found there is no shear force, is 0. Then we come to the point A, little bit right side, and we found the force is working downward, minus 1.167. Then up to here, up to point B, there is no force. As we learned before, we will work with 0 slope, completely horizontally, will slow up to here, right? And then we got minus 8 force. So minus 8. So our calculation will be 1.167 minus 8, right? So what we will get? We'll get minus 9.167. That will get minus 9.167. So from here we go to the straight, and after that we get minus 8. So our result will be now minus 9.167. And up to we go there, we go here, we found moment, but moment will not come in our calculation in the short for shear force, because we are working with shear force, not moment. So this moment we don't need to consider. We go straight, same force, and up to here we found there is no force. So again we go straight horizontally up to here. Whenever we reach there, we found there is another 8. So minus 8, again minus 8 force is there. So what is the force? We'll find 17.167. We found 17.167. So whenever we got, now we have to go 17 minus 17.167, and then again still keep going, there is no other forces here working, so we'll go horizontally with zero slope, horizontally we reach there. At this point we have minus 1.67, but whenever we reach at point D, we found another forces. So minus 1.67 plus, now this plus because this is upward force, so 32.167. Now how much we got the resultant force? We got the resultant force is plus sign, and we got the 15 now 15, so plus 15. So here we go there 0 and then plus 15, we reach there, here is plus 15 shear force. Okay. When we reach there plus 15 shear force, now as we teach you yesterday, when we feed distributed load, we will go upward inclined or downward inclined. So if our force is upward, then we upward inclined, but if our force is working downward, so we will go downward inclined. Here is downward inclining, right? So 15 force is working there, and at this point how much working there? 15, and then minus, here is force is working downward direction, so minus, and 15 into how much this total force? 15 into 1. So 15 into 1 and 15 into 1, finally we got 0, and then we reach to the 0, right? We reach to the 0 and we go the inclined force. Now remember, we will be starting always from 0, and we will end up with 0. If it is not 0, if you don't end up with 0, that means you have to understand you have done somewhere wrong. Okay? You have done somewhere wrong. So this portion is negative and this portion is positive. So our shear force diagram is look like this, and shear force diagram like final. So shear force diagram is completed. Now you tell me, anyone, do you have any question here? Do you understand or not? Tell me please. Please tell me, are you clear or not? Do you have any question somewhere? Doctor, yes, tell me. Tell me. Doctor, about distributed load, can it be negative? What do you mean by? Again, tell me. Come on, Ashraf. Tell me the question. What do you mean by? That means shear force it could be negative. Your question is that shear force here? Yes, of course. Shear force could be negative. Yes, the diagram could be there. Right? Now, the distributed load is working here. Here is downward. That's why we write down here negative. But your question could be, I think your question is distributed load, shear force. Yes, sometimes it could be negative. Yes. If you practice what I have given you, you will find there is that kind of question where shear force will be negative. Right. If you shear force you have drawn, shear force is clear to you. Now we will draw the bending moment diagram. Now bending moment diagram is we don't have enough space there, but I will try to do here the moment diagram. Now here right, we have to draw another reference line 0 0. And as I told you before, bending moment diagram is just the area of the shear force diagram. Area of the shear force diagram. So if we want to do from at point A, it is start with 0. Okay. And what will be happen with at point B? At point B will be the area of the shear force diagram. Area of the shear force diagram. So what is the area? Area is the 1.167 into distance is 1. So distance is minus. So it is minus 1.167. Same result. So suppose here, and I told you, if bending moment diagram is the with zero slope, then zero slope, and we have to go the zero slope. That means horizontally going. Then we have the inclined line. So minus 1.167, 1.167, right? Then here we have. So here what we have. Then if we go to the here is the 1 point. Now we have another external moment. How to calculate the external moment? In shear force diagram, when we draw the shear force diagram, we ignore this 20 kilonewton force. We ignore the 20 kilonewton force, right? We ignore the 20 kilonewton force, but now we have to consider 20 kilonewton force. Where? Here, right? So minus. So at the point at suppose A, B, C, D. This is D point. Suppose this is E point. At E, so we have another force minus 20. So total is minus 21.167. So here is, we will go like this. Here is minus. Don't space. Minus. Here is minus 21.167. And from this point, sorry, here I did miscalculation because it is negative. Sorry, we will do the little bit miscalculation I have done here, and here is the. So here you have the 1.67, and first we have to draw this one. First we have to draw this area. This area is, I draw it. This area. So what is the area of that one? What is the area? Area is again minus. Distance is 0.25, and height is how much? Height is 9.167 into 0.25, right? 0.25. And if you calculate, you get the result, right? How much you calculate? How much? Now remember that when we are working, remember that your exam will start now. So I stop it here now for this time, and we go for the exam. Your exam will start right now. Okay. So are you ready? Are you ready for exam?
Doctor, I have a question.
Yeah.
If we had a problem to your Blackboard when we are uploading the files, how we will do? Like send it for you via email or what?
Yes. If you have problem, then first you must have to take picture. Take picture or screenshot. Is screenshot, okay? As evidence, screenshot that. Take picture as a screenshot that your Blackboard is not working, right? Then send email. Without this evidence, I will not accept. Okay. Then send email. All right. And don't forget the email address. Email address is email will not be acceptable. Will not be acceptable without evidence, right? Without evidence.
Doctor.
Says that write down that your Blackboard is not working, right? Please. Okay.
Yeah, exam
Must
doesn't
to,
help me.
yes, tell me, please, yes.
Exam doesn't help me up to now.
Sorry?
Exam doesn't help me like quiz. Didn't help me up to now.
Did you get the exam question now?
No, we cannot see the question. The exam not appear. Doesn't appear.
Not appear. It should be at 10. Still 1 minute. Let me check. Check there. You got the question? Did you check? Question is available to now you? Yes. Someone say no. I think it is. It should be yes. Doctor, what is the question? Yes. Abdul Fahad, you go to the exam. You go to the exam, and it will be available.
There
I
is
show
no
you
picture,
there.
but
Sorry, don't find it. You go to the exam section. You see, this is your page. This is your page, and then you go to the exam, and you see exam is available now. Tell me, who is the
sure,
person?
there
Sorry,
there's no picture.
there is. Someone saying the question. There is no question. You enter the exam, but no question.
There's no question.
Sure.
Yes.
No question. Why no question? Let me check. Let me check. You are sure there is no question?
Doctor, some students cannot see the figure and the other student can see it.
Okay, so there is a figure, right?
Yeah.
Click to the begin. Click begin. That means there is a question and some student cannot see, right? Let's check what's happening. The question is there, so click on the question. Okay, so read the description is there, 20 minutes, 10 minutes, all the description there, then start begin, right? And
Doctor,
then
can I use pencil?
there, okay, you see the question.
Doctor, can I use pencil?
No pencil. Pencil for sketching, but so if someone cannot see the question, so you can see from the screen. Okay. I read the question for you. Determine the horizontal and vertical component of the reaction for the beam loaded. The beam is shown here. You find the horizontal and vertical load and neglect the weight of the beam in the calculation. support at A is roller. So A support is roller and B support is hinge. Now here is the X. X is the last two digit of your student ID, and here is the 3 plus Y. The Y is the digit of your student ID. Last digit. Remember the difference. Last two X is last two digit of your ID, and Y is the only last digit of your ID. Right? If some student cannot see the question on their screen, you can see from my screen. Okay. What is the question? X. All right. X is last two digit. X is last two digit of your ID. Last two digit of ID, and Y is the last digit. So digit. So be careful about the differences. And if still you have any student has any question to see the screen, if you cannot see the screen, you see from my computer, my screen. If you are not, if you have any problem for the exam, so PDF picture. Okay. Yes, PDF is better. PDF is better. What do you mean by show exam? Allah Muhammad. What do you mean? What do you want to tell me?
Doctor,
Yes.
how do we know if you got the PDF file or not?
I don't know. I have to check.
I sent on.
You sent in the how to say? You sent in the
Blackboard.
in Blackboard. Do you?
Yes, Blackboard.
Okay. Let me check. I think after the 20 minutes, it will
Okay.
appear all together.
This is my ID. You can. Thank you, Doctor.
Doctor, I finished the exam and I sent it through Blackboard. Can you see if it's submitted or no?
Hmm. I think it will appear after the all finish. Okay. Title the name. Hussain Abdullah Bakir. One received. Umar Usama is it received. Abdul Malik received. I got it. Yahya, I got it. Hussain Ali, Hussain Alawi, I got your one. Kamal Ashraf, I got your one. Okay. I'm telling the name, so don't. So I tell you again. Hussain Abdullah bin Bakir, I received. Umar Usama, okay, received. Abdul Malik Khaled, received. Yahya Abdullah, received. Then Hussain Ali bin Hussain, okay, received. Kamal Ashraf, okay, received. Okay. Then Abdullah Nasir, received, right? Sorry? Just wait, okay? And at this time I cannot see the ID, I can see on the name, right?
مسافة يا ابني الديستنس مو الديستنس حطيت 3 زائدا 78 هو لاست ديجيت انا قريت اللاست 2 ديجيت
What are you asking?
Yes. هي last.
Doctor, I could not submit. Who is the client? Why you cannot submit? Well, Hussain, take the bar. What about me? Who are you? Ahmad Dia. Did you submit? It will take maybe a couple of minutes to submit there, right? So your time is finished. Now we cannot submit, I think.
Doctor, did you receive my
What is your name?
question?
All right. Look, I submit a note. You see from the name, you see from this screen.
Doctor.
So, yes.
I just have I just can send one